Alright, welcome. Today we are talking about medians and altitudes of triangles. A median is basically any line that comes from one vertex of the triangle and hits the opposite side at the midpoint. So as you can see, it's always going to split the opposite side in half, but it's not necessarily coming in at a right angle. Just like last time how we had circumcenter and incenter and these very special little points, the medians are all going to hit at a special point that we're going to call the centroid. Right, so it's another point that's sort of in the middle of the triangle. The sort of key to this, the pattern that we'll always see, is that at the centroid, each of these medians is split into two sections, where the larger section is twice as big as the smaller section. So, for example, A to P is twice as big as P to K, B to P is twice as big as P to L, and C to P is twice as big as PL. So the way that we're going to end up using this is they're going to give us a problem. They're going to fill in some lengths and ask us for other lengths. So, if we look at this, Q is the centroid, BE is 9, and we need to find the values of BQ and QE. So B to E, right, I would start here, draw all the way through, so 9 is the length of this whole segment. I need to split it into two sections, and the large section has to be twice as big as the smaller one. So if I am not sure how to do that, I'm just going to say this one's X, and this one's 2X, because 2X is twice as big. I know the total length is 9, so I can just say 2X plus X is equal 9, which tells us X equals 3. I'll look at it again. I need to find QE. Well, QE was just X, which in our case turned out to be 3. BQ was 2X. Well, if X is 3, I double that to get 6. And everything is worked out because the small section is twice as big as the large section, and the total comes out to 9. Alright, so I'm going to let you do the guided practice. Find FQ and QC. They're giving us that FC is 15, so basically plug it in, set it up just like we did. Alright, so another one. We notice that we have a centroid because all of the side lengths are marked as bisected. We know that the length from P to T is 2. And they want us to find the distance from K to P. Well, this one's even quicker than the last one, because we know if we're staring at a median, at a centroid, that the large section of the line is twice as big as the small one. So K to P is going to be twice as big as P to T. Well, if I take 2 and double it, it gets me 4. So KP is 4. And that's all there is to it. So for 2A and 2B, again, use the same picture, fill in the sides you know, and figure out the pieces that they're asking for. Next thing to look at is an altitude. The altitude is also known as the height of the triangle. It's always going to come from one corner of the triangle and go straight across so that it's perpendicular to the opposite side. So here, right, it starts at point B, goes straight down to where it hits AC, and it makes a right angle. If we're looking at an obtuse triangle, the altitude could possibly be on the outside, because remember, if we're starting at the top, we're just going to go straight down. If we're starting on a side, we're just going to go straight across. So you got to watch out for the orientation of the triangle. We can technically draw an altitude from any corner. So for example, I could draw one here from point C. I just have to go straight across to the opposite side and mark the right angle. And the way you can think of that is you can always just rotate the triangle around to where the C was on the top, right? I could redraw the triangle there. If C is on top, A would be here, B would be here, and then the altitude I just drew would be that one. The point where all of our altitudes cross is called the orthocenter. There's nothing particularly special about this point other than it's the point where all the altitudes cross. So there's no like little formulas to memorize like there were for the last one. The only thing that we're going to really have to do with this is find the point of the orthocenter on a graph. So we know that this is the point where all of the altitudes meet. So if we're looking for it, the first thing we probably want to do is draw an altitude as best we can. And if we notice the top of this triangle FG is just going horizontal, so the altitude to that would have to be a vertical line, and it's got to come from point H. Well, if I'm looking for a point of intersection of all the altitudes, I probably need to draw at least one more altitude. So if I do that, say I pick point G, and I go straight across, we can kind of see where the orthocenter should be. Just by looking at our picture. We don't know exactly what it is though. And unfortunately, if we run into this on a free response question, which we probably will, we got to give an exact answer, right? Guessing most likely won't be good enough. So what we're going to have to do is find an equation that will help us solve for the missing point. Good news is we are pretty sure that x equals 1 because it's got to run through point H. And since point H is along a vertical line with the base FG, we know that this is going to be x equals 1. Now we need one other line. So what I'm going to do is just pick one of these other altitudes. I'm going to choose this one. And I'm going to find the equation of that. And to find the equation of a line, remember we need to know at least one point on the line, which we have right here. And we need to know a slope for that line. Since I don't know exactly where the altitude from G is going to cross with FH, instead what I'm going to do is use the fact that it's perpendicular to FH to calculate the slope. So if I take the slope from F to H, it would be -2 minus 4 over 1 minus -2. And if we remember from one of our previous lessons, perpendicular lines always have negative reciprocal slopes, right? So we're going to flip the fraction, drop the negative. That's the slope we're going to use in the equation of our line. So going back to that, I got to pass through point G, so I know y minus 4 has to equal 1/2 of x minus 4. And I know at the point of intersection, x equals 1, so I'm just going to take this guy right here, plug it in over here. So I'm going to say y minus 4 equals 1/2 of 1 minus 4. And then we're just going to solve. So again, 1 minus 4 is negative 3. Half of that is negative 3/2. Add the 4 over. Y equals 5/2. So our final answer x equals 1, y equals 5/2. So we just fill in the point. All right, that's all I have for today. And I will see you next time.